Welcome, my friends. In this video, we're going to practice using the inverse trig functions. Remember that the inverse trig functions will help us solve for the argument or angle of a trigonometric function. So for example, if you have sine of y equals x, if you'd like to solve for y, then you would need the inverse sine of x. And since these trig functions are cyclical and they repeat themselves, there are many different values y, or many different angles, that could give you any given output. But we just want one output from our inverse trig function, so we have to restrict our range in some way. For sine, we restrict it to between negative pi over 2 to pi over 2. For cosine, between 0 and pi. And for tangent, between negative pi over 2 to pi over 2, not including the endpoints. And the domain of each of these inverse trig functions is just the range of the original trig function. They kind of switch around. So sine can typically be between negative 1 and 1. So the domain of inverse sine would be negative 1 to 1. Same idea for cosine, and for tangent we have all real numbers. Okay, so we're going to start by looking at what happens when you compose an inverse trig function onto the initial function, or vice versa. So here's a statement. If x is in the domain of the inverse trig function, then the following statements are true. So first of all, let's just look at the domain of each of those inverse trig functions. Sine and cosine between negative 1 and 1, and tangent can be anything. This is the range of the original trig functions. And this is our statement here, our three statements. So if you take sine of the inverse sine of x, your answer will just be x, assuming that x is between negative 1 and 1. Same thing for cosine, and for tangent, it really applies to any number as long as it's a real number. The tangent of the inverse tangent of x is just going to be equal to x. So for example, sine of the inverse sine of 1/2 is just going to be equal to 1/2. Now if you want to think a little bit more about why that is, remember that inverse sine of 1/2 is asking you sine of what gives you 1/2. Well, sine of pi over 6 would give you 1/2 in the range of inverse sine. It would be pi over 6. So you get pi over 6 for the inside. Sine of pi over 6 would indeed give you 1/2. Okay? And then we could try one for cosine. Cosine of inverse cosine of 0.7. Well, as long as this number is in the domain of cosine, which it is, the inverse cosine, then we are just going to get 0.7 out. This is not a commonly known value on the unit circle, so we don't even really need to evaluate what this is. This is asking us cosine of what gives us 0.7. I don't really care because since this is in the domain of inverse cosine, I know that I'm just going to get the same value out here. Or here's one for tangent. Tangent of inverse tangent of square root 3. As long as that's in the domain of inverse tangent, which everything is in the domain of inverse tangent, so I don't even have to really think too much there, I'm just going to get square root 3 out. Or if you wanted to think a little bit deeper about exactly what's going on here, this is asking you tangent of what gives you the square root of 3. Well, that would be tangent of pi over 3. So then we would have tangent of pi over 3, which gives us square root of 3 back again. Okay. Now the only thing you have to watch out for is whether or not this value on the inside is outside of the domain of your function. So for example, let's say we have sine of inverse sine of 1.5. Well, that's not going to work out because this is asking us on the inside, sine of what gives you 1.5? Well, sine can never be bigger than 1. The domain of inverse sine is from negative 1 to 1. So there is no value that you could plug into a sine function to get 1.5. So this is going to be undefined. Okay. So really you just have two options with these types of problems when it's composed in this way, with the original function on the outside and the inverse on the inside. You're either going to have the case where it's just going to be the same answer as kind of the inside of the function. That would be if you're inside the domain. Okay? And the other case is if you're outside of the domain, you are going to be undefined. Okay? Now this does not apply if you switch things around. It's a little bit more complicated if we have the inverse function on the outside. Okay? So I remember if you have the regular trig function on the outside and the inverse on the inside, that's the easier case. You're either going to be undefined or you're going to be having the exact same value as in the inside of the argument as your answer. Okay? All right, so let's take a look at what happens if we have things switched around. So now if x is in the range of the inverse trig function, the following statements are true. So before we had the domain, and now we have the range. So just a reminder of the range of the three inverse trig functions. Sine and tangent are between negative pi over 2 to pi over 2, and cosine is between 0 and pi. So if we are within those ranges, then inverse sine of sine of x is equal to x, inverse cosine of cosine of x is equal to x, and inverse tangent of tangent of x is equal to x. Notice the difference here from the previous slide, now we have the inverse functions on the outside and the regular functions on the inside. Okay, so if you have the inverse on the outside, then this is going to apply. If we have the inverse on the inside, then we have the previous case. Okay, so for example, if you have inverse sine of pi over 6, as long as this pi over 6 is in the range of inverse sine, the answer is just going to be pi over 6. And indeed it is. Pi over 6 is between negative pi over 2 and pi over 2. If you'd like to think about a little bit more about what's going on, you could evaluate the inside directly. Sine of pi over 6 is equal to 1/2, right? Sine of pi over 6 is 1/2. So inverse sine of 1/2 would be asking you sine of what gives you 1/2 within the range of inverse sine, and that would have to be pi over 6. Or here we have inverse cosine of 2 pi over 3. So again, we have the inverse on the outside, so we have to look at the inside and make sure that that is in the range of the inverse function. Indeed it is. 2 pi over 3 is within the range of 0 to pi, so that means our answer will just be 2 pi over 3. If you'd like to think through the logic a little bit more, cosine of 2 pi over 3, that's going to be negative 1/2, right? And so this is asking us inverse cosine of negative 1/2, or cosine of what gives you negative 1/2 for an angle between 0 and pi? Well, cosine of 2 pi over 3 is the angle between 0 and pi that gives you negative 1/2. Okay, and then finally we have inverse tangent of pi over 5. Now pi over 5 is not a commonly known angle, but thankfully if we look at the range of tangent, we are within that range, right? Pi over 5 is between negative pi over 2 to pi over 2, so therefore the answer will also be pi over 5. Okay, the problem comes when you are not within the range. Then you have to do a little bit more thinking. It's not as simple as the previous case where we had things switched around and it was just undefined. Now we have to do a little bit more thinking. So for example, let's say we have the inverse sine of 3 pi over 4. Okay, so if we check out the range of inverse sine, 3 pi over 4 falls outside of that. Negative pi over 2 to pi over 2, that's quadrants 4 and 1. 3 pi over 4 is in quadrant 2. Okay, we're going to have to kind of brute force this and evaluate this directly. So let's look at the inside. Sine of 3 pi over 4. So 3 pi over 4, sine is going to be positive. We're in quadrant 2. The reference angle is pi over 4. It's just going to be positive square root 2 over 2. So we have inverse sine of positive square root 2 over 2, which asks us sine of what within negative pi over 2 to pi over 2 gives us square root 2 over 2. Okay, and that angle would have to just be regular old pi over 4. Okay, so kind of in conclusion here, if you have the inverse function on the outside composed onto the regular function, as long as you're within the range of the inverse function, the answer will also be the same as the argument, as we had in all of these three cases. But if you are outside of that argument, then you're going to have to directly evaluate the inside and then think about the inverse function from there, right? So you'll have to kind of do a little bit more work in that case. All right, let's take a look at a few more examples here. So I've got both the domain and range of all three inverse trig functions here on the side. So let's see if we can find the inverse cosine of 7 pi over 4. Okay, when you have the inverse on the outside, that means you are looking at the range. So let's look at the range of inverse cosine. It's from 0 to pi. So that means if our angle is between 0 to pi, this will just be our answer. But indeed, our angle is not between 0 to pi. It is outside of that. 7 pi over 4 is in the fourth quadrant, so it is not between 0 and pi. So we're going to have to evaluate this directly. So what is the cosine of 7 pi over 4? Well, that is just positive square root 2 over 2. Okay, so now we have to find the inverse cosine of square root 2 over 2. Okay, so this asks us cosine of what gives us the square root of 2 over 2. But we need an angle that's between 0 and pi. So what angle between 0 and pi gives us square root 2 over 2 when we put it into cosine? And that's just going to be pi over 4. Okay, so pi over 4 is our answer. How about sine of inverse sine of 1/2? Well, if we have the regular trig function on the outside, that means we're looking at the domain. Okay, so what is the domain of inverse sine? The domain of inverse sine is between -1 and 1. So that means as long as this value is between -1 and 1, that is just going to be our answer. And that is the case here, right? 1/2 is between -1 and 1, so our answer is just going to be 1/2. No further work required. How about the arctangent of 4 pi over 3? Okay, remember arctangent is just a fancy way of saying inverse tangent. So we have the inverse tangent of 4 pi over 3. So we would look at our inverse tangent function and we would see that the range is negative pi over 2 to pi over 2. So as long as this angle is between negative pi over 2 to pi over 2, then we can just copy this over as our answer. But in this case, that is not true. 4 pi over 3 is outside of this range. So we will have to evaluate this directly. So hopefully you're up on your tangent angles. What is the tangent of 4 pi over 3? The reference angle is going to be pi over 3. This is in the third quadrant. Tangent has the same sign in quadrants 1 and quadrants 3 because sine and cosine would have the same signs. So this is going to be the same thing as tangent of pi over 3. What is the tangent of pi over 3? That is just the square root of 3. Okay, so now we have arctangent of square root 3. So this asks us tangent of what gives me the square root of 3 in the range of negative pi over 2 to pi over 2. And I already mentioned what that is. That is just pi over 3, right? Tangent of pi over 3 is equal to the square root of 3. So that is our answer. Now let's go on to the next one. We have cosine of arccosine or inverse cosine of negative square root 3 over 2. So since we have the regular trig function on the outside, that is when we look at the domain. So we're looking at the domain of inverse cosine. It's from negative 1 to 1. Negative square root 3 over 2 indeed is in that domain. So that means we can just copy that over and that will be our answer. Next one, we have sine of inverse sine of negative 3. So we have the regular trig function on the outside, which means we need to look at the domain. What is the domain of inverse sine? Well, it is between negative 1 and 1, but negative 3 is outside of that range, right? So if we're looking at just this inside, this asks us sine of what gives me negative 3? Well, sine of nothing is going to give you negative 3, right? Sine cannot be anything bigger than 1 or smaller than negative 1. So this is going to be undefined. We are not within the domain of our inverse trig function. Okay, let's try one more problem. We have inverse tangent of negative 10 pi over 9. So since we have the inverse tangent on the outside, that means we are looking at the range of inverse tangent, okay? And what is the range? It's from negative pi over 2 to pi over 2. So is this angle in that range? No, it is not. Negative 10 pi over 9 is not between negative pi over 2 to pi over 2. So where is this angle anyways? Let's look at a unit circle here. So negative 10 pi over 9 means we are going clockwise for a negative angle, right? So we are going to be starting at the positive x-axis, and then we would be traveling around, and we would eventually get to the negative x-axis. That would be negative 9 pi over 9, or negative pi. But we have to go a little bit further than that, so we're going to be a little bit higher, so something maybe around here. This would be our angle, negative 10 pi over 9, okay? And that does not fall in our range of negative pi over 2 to pi over 2. So the strategy here is to rewrite this angle as an angle in either the first or fourth quadrant, right? So that it actually is in that range, kind of an angle that's going to have the same result that's going to be in the first or the fourth quadrant, okay? And you may or may not know this, but if you always just draw a line straight through your circle, you will get the corresponding other angle for tangent that has the same sign. So if I just draw this straight through the circle and I go down here, I will actually get the other angle that is has the same sign for tangent on one revolution of the circle, right? And why does that work? Well, tangent is always the same sign in kind of the diagonals of the circle, right? So if you are in quadrant 2, tangent is going to be negative because sine and cosine would be different. They'd be opposite, right? And same thing with quadrant 4. Sine and cosine will be opposite, so you're going to have the same, you're still going to be negative for tangent in either of those places, right? So if we go over here, this is going to be negative pi over 9 over here, right? So we could actually rewrite this as inverse tangent of negative pi over 9. And negative pi over 9 is within the range of negative pi over 2 to pi over 2. So in this case, we have rewritten the problem in a way such that this does work out, and the answer is just going to be simply negative pi over 9. Okay, let's take a look at some compositions of functions where they are not the same function. So how do you deal with this? Inverse sine of cosine of 5 pi over 4. Well, we don't have the same function on either place, so what I would do is I would just evaluate the inside function and see if it's going to work out nicely. So what is the cosine of 5 pi over 4? So let's just start with that, the inside. Well, that should be a well-known angle. 5 pi over 4 has a reference angle of pi over 4. Cosine of pi over 4 is square root 2 over 2. But of course, we are in quadrant 3 if we are at 5 pi over 4, right? So quadrant 3, cosine is going to be negative, so this is going to be negative square root 2 over 2. Okay, so we can kind of substitute that into our inside. We have inverse sine of negative square root 2 over 2. So this as sine of what gives me negative square root 2 over 2. Again, within that range of negative pi over 2 to pi over 2. So sine of what gives me negative square root 2 over 2? Well, that's going to be negative pi over 4. Negative pi over 4 gives me a sine of that gives me negative square root 2 over 2 in the range of negative pi over 2 to pi over 2, which we have for inverse sine. Okay? So how about this one? How about the exact value of tangent of inverse sine or arc sine of square root 3 over 2. So now we have it kind of flipped the other way around. Now we have the regular trig function on the outside. Okay, so still I would just evaluate it kind of one piece at a time. I would think arc sine of square root 3 over 2. That's asking sine of what gives me square root 3 over 2. And that would be, again, since we're dealing with sine, either somewhere between negative pi over 2 to pi over 2. So sine of what gives me square root 3 over 2? Well, hopefully you said that's going to be pi over 3. Right, so we would have pi over 3 for that. So we kind of place that on the inside. So what is tangent of pi over 3? Hopefully you have that memorized. Tangent of pi over 3 is just the square root of 3. Okay, so if you have two different functions and you have a commonly known angle on the inside, or I guess angle in this case, or kind of value on the unit circle in this case, then just kind of evaluate it directly, and everything should work out. Now the difficulty comes when this is not a commonly known value, angle or value on the circle. Then what do you do? And that is the next two problems we will look at. Okay, let's take a look at another type of problem. So say that we have sine of inverse cosine of 4 over 5. In this problem, we cannot evaluate the inverse cosine of 4 over 5, right? This asks us cosine of what angle gives us 4 over 5, and that is not a commonly known angle. So we cannot evaluate this directly. So instead, we have to take a different approach. So what approach do we take? Well, what I do is I just label the inside as theta, right? We can think of this whole argument here as just some angle that we're taking sine of. Sine of cosine inverse of 4/5, that's going to be our theta. So let theta equal the inverse cosine of 4 over 5. Okay? And just think about what this is asking you. This is saying cosine of some angle gives me 4/5. Or in other words, cosine of theta is equal to 4 over 5, right? So basically, this is just asking us, try to find the angle such that cosine of that angle will give me 4 over 5. But we can actually go one further step than this. We know a little bit more about this angle. We know specifically which quadrant it's in. Now you might remember inverse cosine is defined for quadrants 1 and 2. Inverse cosine gives you a range from 0 to pi, right? So we're just in quadrants 1 and 2, from 0 to pi. But if we know that we have a positive value for cosine, where is cosine positive? Well, that would have to be quadrant 1. It's not going to be quadrant 2, so we actually know that we are in quadrant 1. Okay, so guess what? We are going to have to draw a right triangle. So here is our triangle, kind of stemming off. You could think of this on a circle off into quadrant 1. And we have our angle theta right here. And we can figure out what the side lengths are based on our cosine. So we know cosine of theta is 4 over 5. And we know that cosine is adjacent over hypotenuse. So that must mean the adjacent side is 4. And the hypotenuse must be 5. Okay? If we can find sine of theta, we will have the answer. Think about this for a second, right? Theta is the inside, right? So we want to find sine of theta. That is what we're trying to find. Sine of the inside. Sine of theta is what we're trying to find. So if we find sine of theta, then we will have the answer to this whole question, right? This whole question is asking us for sine of theta. Theta is inverse cosine of 4 over 5, okay? So our goal is to find sine of theta. To find sine of theta, we would have to have the opposite side and the hypotenuse. So we got to find the opposite side. So let's use the Pythagorean theorem in order to find that, okay? And that's going to be our side b. So we're going to have 4 squared plus b squared is equal to the hypotenuse 5 squared. And we can simplify this. We'll have 16 plus b squared is equal to 25. We can subtract 16 from both sides of the equation. 25 minus 16 is going to give us 9. We can take the square root of both sides. We will get that b is equal to plus or minus 3. And of course, if we are in quadrant 1, then this is going to have to be a positive b, right? So we're going to be positive 3 here, okay? So then we can put that onto our triangle, and then we can find sine of theta. Sine of theta is going to be opposite of 3 divided by the hypotenuse of 5. So we're just going to have 3/5, and that will be our final answer, right? Because that is what we're trying to find. We're trying to find sine of theta. Theta is inverse cosine of 4/5, and we found it. Sine of theta is 3/5. All right, let's try one more problem similar to that last one. So we have secant of inverse tangent of -3. Okay, so we can't work from the inside really directly because we do not know what the inverse tangent of -3 is. This is asking tangent of what gives me -3, and that is not a commonly known angle on the unit circle. Okay, so we'll have to do the same thing as last time. We'll have to say that theta, the inside of our secant function, is equal to the inverse tangent of -3. Okay, and again, remember what this is asking. This is saying tangent of what angle gives me -3, so we could rewrite this as tangent of theta is equal to -3. And then again, just like last time, we have to think about which quadrant this is going to put us in. Okay, so inverse tangent, the range of inverse tangent is from -π/2 to π/2. So that would be either quadrant 4 or quadrant 1. Okay, so which of those two quadrants, either quadrant 4 or quadrant 1, is tangent negative? Well, in quadrant 1, all the trig functions are positive, so it must be quadrant 4. Indeed, it is quadrant 4. Tangent is negative in quadrant 4 because sine and cosine will have opposite signs. So we must be in quadrant 4. So again, just like last time, draw a right triangle, and this one will extend off into quadrant 4. You could think of this as the origin extending off to a point on a circle if you want to. We have a triangle that's kind of oriented in this way. And we can use the idea that tangent of theta is equal to -3 to kind of fill in the sides of our triangle. I would think of this as tangent of theta is equal to -3/1. So that opposite over adjacent would be -3/1. So we would have -3 as our opposite side, and our adjacent side would be 1. Now we need to find secant of theta. That's what we're trying to find. Theta is inverse tangent of -3. So if we can find secant of theta based on this triangle, we will have our final answer. That's what we're asked for, secant of theta, where theta is inverse tangent of -3. So let's find secant of theta. To do that, we need to know the hypotenuse, because secant is hypotenuse over adjacent, right? Cosine is adjacent over hypotenuse, so secant is the hypotenuse over the adjacent side. Okay, so we've got to find the hypotenuse, and to do that, we will use none other than the Pythagorean theorem. So this is going to be our C. This will be A and B for the 1 and the -3. So we will have 1 squared plus -3 squared in parentheses is equal to C squared. So 1 squared is 1, 3 squared or -3 squared is 9, and C squared is just C squared. Adding these together, we will have 10 is equal to C squared. Let's take the square root of both sides. We will get that C is equal to plus or minus the square root of 10. But C is a hypotenuse, so typically we think of that as a positive value, at least in this context. So we are going to have positive square root 10 here. Okay, so we can put that onto our triangle. And then we can think of secant of theta. So secant of theta is hypotenuse over adjacent. Since cosine of theta would be adjacent over hypotenuse, secant of theta is the reciprocal function. It's going to be hypotenuse over adjacent. So our answer is going to be the square root of 10 over 1, or just the square root of 10. Secant of theta, secant of this whole thing is theta, right? This is theta, so secant of theta is the square root of 10. And we are finished. All right, my friends, that finishes this video of practice with the inverse trig functions.